Convert the following complex numbers into polar form. So we're starting with -3 plus 3i. And when you're doing it in this direction, I always suggest that you sketch where the thing is. And the reason for that is if you think about the quadrants A, S, T, C. If you're trying to work out the angle, you're going to be doing an inverse tan. And the period of tan is pi, not 2 pi like the sine and the cosine. But of course, all the way round is 2 pi. So you really need to know where it is to get the angle right. So -3 plus 3i would be up here. Now, if this distance is 3 and this one is 3, it should be clear that this angle is 45 degrees or pi by 4 because we have an isosceles right-angled triangle there. That means the angle from the positive real axis is going to be 3 pi by 4. Now the length r is going to be the square root of 3 squared plus 3 squared, which is the square root of 18, which is the square root of 9, square root of 2, which is 3 root 2. So this number is going to be 3 root 2 cis, and I'll use that contraction for cos plus I sine, cis 3 pi by 4. Now the next one that we have is 1 take away I root 3. Just by the way, where we found in the first example the way to convert it from polar into rectangular, there's a similar function just here. And you can see that we use that. But it was in exactly the same place. You go to either action or interactive, complex, and it's down the bottom of the little menu that you get there. Okay, so let's think about this one. So I'm going to do a sketch. 1 take away root 3i. So that would put it here, where that length is 1. That length is root 3. And that should tell you that this angle here is pi by 3, just using ordinary right-angled trigonometry. So what about the r? That would be the square root of root 3 squared plus 1 squared. So root 4, which is 2. So this is going to be 2 cis. Think about the fact that we're going in this direction, negative pi by 3. So what about I? Well, I is just here on the imaginary axis. So the angle there would be pi by 2. And it's 1i, so the length there is 1. So that one is just cis pi by 2. What about 5? So that would be here. The magnitude is 5. And it's actually on the positive real axis. So that one is 5 cis 0. I'm giving the principal argument here. You could go all the way around and call that 2 pi, or indeed any multiple of 2 pi, but we're going to give 0. And then we've got 3 minus 4i. So 3 across and 4 down means it's down here. We're going to be interested in this angle, which I'll call theta for now. That's 3, that's 4. The magnitude, which is this one, is just going to be, by Pythagoras, r is equal to the square root of 3 squared plus 4 squared. Root 25 is 5. And for the angle, we're actually going to need to work it out. Inverse tangent of the opposite divided by the adjacent, and calculate. And that gives me 0.927 radians, correct to 3 decimal places. And so I would give this one as 5 cis 0.927.